Good morning to all of you. I welcome you to this session on RDBMS. In today's session, we are going to discuss the group by clause along with the having clause. We'll be discussing the distinct clause in SQL. And then also along with the group by clause, we'll be discussing the aggregate functions or the group function, single group functions. And then we would be discussing the data types in Oracle SQL and some DML statements. DML stands for data manipulation language. So I'll be discussing create table and insert statements with you today. So kindly be attentive and keep on noting whatever you think is relevant. So as we discussed in yesterday's lecture, we were working with the select statement and we were working with the emp table. So if you just list the contents of the emp table, you have a listing like this, right? And we did discuss the where clause. Along with the order by clause. So if I write this query, select star from emp where sal is greater than 2000, order by ename, it would mean that it would pick up all the rows which satisfy this condition, that is salary greater than 2000, and it would order the output by ename in ascending order. So kindly have a look at the output. You can see that the names are appearing alphabetically from A to Z. And if I just make it like this, then it would be the reverse order, Z to A for ename, the ordering. And the rows would be the same which are satisfying this condition. Okay, right? So this is all we discussed in yesterday's class. Now let's discuss the group by clause today. Okay, so we are going to discuss the group by clause. So why should we group our data? First of all, understand this thing that your entire table is a single group. Okay, your entire table is a single group. And group by clause is used to divide your table into smaller groups. Right? Group by clause is used to divide your table into smaller groups. And how it is used? Let's see its syntax. It's a part of the select statement itself. I'm going to group this M table on department number. Okay. So I think a few things are there for you to pick up first. Now, if I group this table, if I make groups on the basis of department number, then you will agree with me that there will be only three groups. One group be for department 10, one for 20, and one for 30. Okay, understood? If I make the group on the basis of department number, there are three department numbers only. So we'll have three groups, 10, 20, and 30. If I make the grouping on the basis of the job column, okay, then I'll have 1, 2, 3, 4, and 5. 5 groups, right? Understood? So let me just show you these things. Select, say job from M, group by job. Okay. So whenever you need to use this group by, only that column can come here, which is used in the grouping. First point to be remembered. So if you are grouping by, on the basis of job, a select can have just one column here, job, plus you can have some additional aggregate functions, which I'm going to discuss next. Okay. So first understand this, how to write the select when you're doing the group by operation. You must write the column here on which the grouping has been done. No other column can come here. For example, if I do something like this, okay, this will give you an error because you are not grouping on ename. So ename cannot come after select. I repeat, when you are doing grouping operation, whatever column you are using after group by, for example, we are using job here, only that column can appear here. No other column can appear here. And along with this column, certain aggregate functions can appear here. Okay, understood? First thing. And similarly, if I group on the basis of department number, you will see that only 3 groups would be there, right? Department 30, 20, and 10. Now the next question is why we should do grouping. You see, sometimes we are interested in extracting some summary information from a set of data. For example, I would like to see that what is the maximum salary paid in department number 30, or what is the minimum salary paid in department number 10, or what is the total salary that is paid to all the employees of department number 30. Or in general, maybe I'm interested in displaying the maximum, minimum, and total salary department wise. Okay. The similar basis, I would be interested in finding, say, maximum salary given job wise. So if you see for a salesman, right? For salesman, 1600 is one salary, 1250 is another salary, 1500 is another salary, right? And 1250 is another salary. So if I pick up the maximum salary from here, it should return 1600. That is the idea. So if you need to pick up summary information, okay, summary information from your groups. First thing is you create groups so that you can extract some information, and that information is a summarized information. So if you need to have this summary information, then we use something known as aggregate functions. Okay, aggregate function means which work on a group, right? We can use aggregate functions to extract summary information out of a group. Okay, so we have these functions. These are the aggregate functions that I'm listing. You can just note them down. Right? These are the aggregate functions. Kindly remember them. This count, sum, average, max, min, standard deviation, and variance. These are the 7 aggregate functions available in Oracle SQL, which you can apply on your groups to extract summary information. So let's take a few examples now. Let's take a few examples. We'll just keep the table in front of us so that you people can participate in this. So my first query is, you can write it down. I need to display maximum, minimum, and average salary department wise. Maximum, minimum, and average salary department wise. Okay, I need to display maximum, minimum, and average salary department wise. So I need to do grouping on the department. Okay, I need to do grouping on department, and I need to use which aggregate functions? Max, min, and average. Okay, obviously on the salary column. Okay, so kindly have a look how to do it. I can write here, select these are the aggregate functions that I'm using. Okay, max, min, av, right? Okay, department number, and then I must write this table names, and then I can write here group by department. Okay, this is the query which would be giving answer to my question, display maximum, minimum, average salary department wise. So I'm grouped on the basis of department number. 3 groups would be formed. Okay, and out of those 3 groups, it would be picking up the maximum salary, the minimum salary, and the average salary. Okay. So you see, when I use this query, it gives you this answer. It has done the grouping on the basis of department number. And then from each department, it has picked up the maximum salary, the minimum salary, and the average salary, right? What I can do is I can include some function here. Okay, some function here. That is, now it will sum up the salary also. It will sum up the salary also, right? So if you use it here, you can see that the sum of the salary is 9400 in department number 30, Okay. Okay. So this is 9400, and what are the total values in department 30? We can display that also. That can be done with the help of the count. Okay. So I can use a count function here. Okay. Now you can see the complete picture. Department 30, there are total 6 records. Okay. So 9400 divided by 6 is the average salary. Keep this in mind that this is okay when we don't have null values. If there are null values, then obviously we will have different answers here that we'll discuss at the end of today's session, right? So this is how we have used the aggregate functions along with the group by, okay, to answer this particular query. You can see this now. We have added the sum and count also. Okay, fine. So let me add another query here. Say display or display say total number of employees job wise. Total number of employees job wise. This is my next query. Okay. So we can write this, select job, comma count star from M, group by job. Okay. So this will tell us the total number of people which are in different jobs. So we have got 4 clerks, 4 salesmen, 1 president, 3 managers, and 2 analysts. The total of 14 records should be there. We do have a null value also, I think, which we added yesterday here. Let's check, because I would be going with that null value also here. No, it's not. We didn't save it, right? We inserted it. Yesterday we inserted it, but we need to use a commit statement to save our DML statements. That I'll discuss in today's session itself. So if you are clear with this group by, because we can have so many examples on it, okay, that I'll come up with in the tute sheet that I discussed with you guys, right? Okay, so this is by group by. Now further, if we need to pick up information, like you see this example on screen, we have listed the count of people job wise, right? Now my query would be, I can just change this. I can just change this to for departments employing more than 2 people. For my example, I now want to display the total number of employees job wise, one thing, but I want only those departments which are employing more than 2 people. So if I use this query here, then it will be the output would have the clerk, the salesman, and the manager, only 3 rows. Okay, so how to do it? This is your same query. Just add a having clause here. So you want to have a having clause on the number of people. So simply do like this. Okay, having count star greater than 2. Just hold on for a second. All right, so if we use this query here, right, select job comma count star from M, group by job having count star greater than 2, you see the output now. Okay, so here we have put a restriction on the data contained within the groups. So one distinction between the where and the having clause. Where is used on your entire table. Okay, where is used on your entire table. If you need to pick up some conditional information out of your groups, then you use this having clause. Okay, remember this. Then you use this having clause. I've discussed this thing once with you. Now you need to practice it a lot so that you are comfortable with it. Okay, remember having is used on groups. So one more query before I just move on further to the data types in Oracle. Maybe I can ask this query from you. Display maximum salary and average salary for all departments having maximum salary greater than 3,000. Okay, so display maximum salary and average salary. So you understand that we need to find department wise maximum and average salaries, but it should display the maximum salary greater than 3,000. So if you look for a previous query here that we have written, like this one, okay, so we need to go with max and average. So I can just change it here, max and average group by department number. Okay, so if we use this, it will give you this. Okay, so my condition is that maximum salary should be greater than 3,000. So these two rows should not come, because this is 2850 maximum salary, this is 3,000, right? So what I can do here is I can put some further condition here. Okay, so we can put a condition here having max sal greater than 2,000. Okay. Sorry, we wanted to pay max sal greater than 3,000, right? Yeah. Okay, so only one row would be returned. So you can see how we can further put conditions on our groups with the help of the having clause. The distinction between having and where: having is used on groups, where is used on your entire table. Okay, so that is the point. Like, this is how the grouping can be done. So I think now the entire select statement is clear to you. Okay, select column list from table name, where condition, group by column name, having condition, order by column name, ascending, descending. This should be, clear to you all the times. You should not be remembering it. This should come automatically to you while you're using the select statement, right? So let's now move ahead and see the data types in Oracle. Important for you when you are designing your tables, data types in Oracle. Okay, this is the next topic. So for this, I'll open up maybe a new document here. Okay. Easier to, okay. So we have many data types in Oracle. I'll discuss the basic 4 data types first with you. Data types in Oracle. The first one would be char, then the varchar2, then number, and then date. There's a long list of data types that you can use, but these are the 4 basic data types. Okay, fine. Right. So if you need to enter character information, right, then you can use either char data type or varchar2 data type. Okay, see the name varchar2. In the previous versions of Oracle, okay, we had this only varchar data type, but now we have the varchar2. So remember this thing: character and varchar2 are the same, okay, with one technical difference between them. Okay, that is that this is a fixed size. Whatever size you give to a char, okay, it will use that size, and this is a variable size. Varchar2 means variable size. Okay, how do we differentiate? For example, if I declare a data as a column as char20, and I declare a column as varchar220, okay, the difference is, the similarity is that both of them can have a maximum allocation of 20 characters. Okay, but let's suppose that the char data type, it uses only 10 out of these 20. Okay, then the remaining 10 are not given back to system. Okay, they are padded as blanks along with that value. Okay, so if we use a size of 10, then the remaining 10 are added as blanks and not returned to the system. Remember? Okay, good. So if you declare a column as size char 20, but you use only 10, then the remaining 10 are padded as blanks and they are not returned to the system. And if you use the similar one with the varchar2, okay, so the remaining 10 are returned to the system. I think the differentiation between them is clear. Now you would ask where to use varchar2 and where to use char. Okay, so whenever you have some fixed information which you know is not going to change, for example, columns like married. Okay, so married, the answer would be yes or no. Sex, the answer would be male or female, like this, right? Okay, and wherever you have variable information, for example, name. Okay, because some people could have a 10 character name, some people could have a 15 character name. So there you can use this varchar2, right? Understood? And the maximum size for char is 2000 characters. Okay, and for varchar2 the maximum size is 4000 characters. Kindly keep on noting these things. Maximum size, that is the maximum number of characters that a char type in Oracle can take, is 2000. The varchar maximum size is 4000. Okay, and here we have a default of 1. That is, if you don't specify any size with your char data type, it would be automatically picked up as 1 character, right? There is no default in varchar2. You need to mention the size. Remember, you need to mention the size in varchar2, no default, right? The next is the number data type. So if you want to enter numeric data, then you can use the number data type. How do you use it? You use it like this. You specify 2 things along with your number data type. The first one is the precision. The second one is the scale. Precision can be 1 to 38 characters or digits, right? And scale could be -84 to +127. Okay, scale is the number of zeros that can come after the decimal. Remember, scale in your number data type is the number of zeros that can come after decimal. And if it is a very small number, then the number of zeros that can come after the decimal. For example, 126.98. So here you have the positive scale. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the scale here. Okay. And for a small number, if it is like this, okay. So here the scale is 1, 2, 3, 4, 5, 6, 7, -7, something like this. You need not bother too much about it, but you must understand what the scale and the precision means. Precision means the maximum number of digits that your number can have. So that is 38 in Oracle SQL. Okay, we'll be looking at all these things. Next is date. So date is like, you know, when you need to specify some dates, very important data type in Oracle. And the default way that you can enter dates is this. Okay, this is a default format. You can convert it to any other format, but this is the default format, right? dd-mon-y. By default, the size of the date is 7 bytes in Oracle. Okay, and you can enter dates from 1st Jan 4712 BC to 31st December 9999 AD. Remember this. This is the range for dates that you can give. So you can see the strength of Oracle. Okay, you can enter a date as you know, in the past as 4712 BC and in future up to 9999 AD. Okay, this is the date range that you can mention in Oracle SQL, right? So let's see how we can use them in our Oracle SQL environment. Okay, So with to understand this, I'll be using the create table statement, right? I'll be creating a table of my own now. So you can kindly note this down. Create table, then a table name. Say we can write a table name as 4CSE2. Just note the syntax. Create table 4CSE2. Then let's write here roll number, and I can pick up a number here, okay, as the data type. Then I can write here name. I can write here varchar2 20, right? Only two columns I've taken. So just see the syntax here. The create table, the statement is written like create table followed by the table name, okay? Then opening parenthesis and the closing parenthesis within which you must declare all the columns along with their data types, along with some constraints that you want to put. Constraints we'll discuss maybe in the next lecture, okay? So roll number, and then there could be some constraints also. So I've taken two columns here in my table for CSE2. One is roll number with the data type as number, and one is name with data type as varchar2 20. So I am using 20 characters to store my name. Okay, fine. So let's create this table. Let's use this name. Okay, so we have created it. So obviously table name must start with an alphabet, okay, not with a number. That's the problem here. So create table CSE2 like this. Okay, so you can now describe this. I hope most of you are doing it on screen right now on your laptops. It would be good if you're doing it right now. So describe. So see here, you can see it clearly that the column name is roll number, the type is number, the column name is name, it is varchar2 20. Okay, fine. Now let's check a few things. Okay. So if you need to remove this table, keep on noting, please. I'll be telling a lot of things in the next half an hour. So if you want to remove this table, okay, you can use drop. You can use here drop table CSE2. Okay, this will remove the table. Okay, so it's a drop table. You see, there are some commands. For example, the create command that we have used, kindly note the drop command that we've used, they come into the category of DDL commands. Okay, and there are certain commands which come in the category of DML commands, and there are certain commands which come in the category of DCL commands. DDL stands for data definition language. DML stands for data manipulation language. DCL stands for data control language. Okay. Remember, the DDL commands are automatically committed. That means the moment you use this command, its change is effected in the database. You cannot revert it. You cannot roll it back. Remember this thing. Whereas DML commands, they can be rolled back. Okay. Till the time you confirm that you are okay with the DML command, it is not saved in the database. Okay, you can roll it back, whatever action you have done. So both the commands DDL, the moment you use create table, the table is created. The moment you use drop table, the table is dropped. You cannot revert now. Okay, so let's see one more thing now. I'll discuss something with you so that I'm using here create table, say CSE2. Okay, and then I just press enter twice. Now, like when we are doing a lot of work, we must do it in the editor instead of the SQL command line. Okay, so to invoke the editor, just use ed. Okay, just use ed editor. Okay, it will invoke the editor, and whatever last thing that you have written here on the command line will appear there. Okay, so see if I write ed here. So it's a better way to write here. Okay, you can just increase the font a little bit. so that the things are more clear, a little bit more. Yeah, fine. So create table. So it's easier to write here so that you can make corrections also. And I'll use here roll number. I'll use here 39. Remember the precision was 38 digits. And I'll use the precision here as 4001. Okay. Remember one thing very clearly, when you're writing something in the end, then don't use a semicolon here. Okay. Don't use a semicolon here to end. That's it. Just simply save it. You can save by pressing Alt FX. Okay. Or alternatively, if you're comfortable with mouse, then file, then save. Okay. And then exit. That is what Alt FX is. So Alt key, then press the F key and then the X key. Okay, Alt F would invoke the file menu, X would invoke exit. So when you exit, it will ask you to save. Okay, and then you can click enter here. And to end this, simply put a slash here. Okay. So you can see the first error, numeric precision specifier is out of range. So you cannot exceed 38, right? So I've used 39 here, that is why the error. Okay, again I'll use ed so that I can just go here and correct the things. So I'll use here say 36. Now again the error is going to come, you know that, just put a slash here to run, and the size is too long. Okay, it should not exceed 4000. Maximum it can be 4000, right? So I can use exact 4000, it should work. Okay, so the table is created. So this is how highlighted the range for the types. Okay, and then again maybe I can create another table here, CSE1 2, and I can use the name just to show you the defaults. That's it, name cap. Okay, no size I'm putting here, so it should pick up a size of 1 automatically. Okay, I'm going to describe this table CSE1 2. You can see the size is 1 automatically. I have not specified any size here. So by default, the char type is having a size of 1 if you don't specify. Okay. And varchar 2, you cannot have a default. All right. So let's now create a table. I'll be creating a student table. Okay. This is for your reference. Student table in which I'll be storing the roll number, the name, then the date of birth of the student, and then the maybe the marks of the student. So with that we have all the data types here, and maybe we can have the sex field also here. So this I'll do, right? I'll create this table with the following columns. So let's do that. So as usual, I'll just begin the command. Okay, and then I'll stop here. I'll put on the ed command to invoke the editor. Easier to write here. So create table student. So define one data type in one line. You can write this entire in one line itself, but it's better to divide each data type in one line, so that if error comes, then you can pick up which line the error is in. So write it in different lines. So you can write here roll number, then number, right? Then you can write here name, varchar 220 you can pick up. Separate the data, this columns by commas. Okay, name, and then we have sex. So sex I can take as char without giving any size, right? And then maybe I can write here the DOB. DOB goes with the date column. Simply write date, that will be picked up as a date column. Okay, and the last one is marks. So I can put marks as number, and say I can use here 5, or I can use a 6,2 here. I'll explain what this will do. So this is my create table student definition, the DDL. Okay, and what I can do here is I can just exit out of it and save it, and then I can press a slash to run. So you can see the table has been created. Okay, then we can describe this table, describe student. So you can see the things out here. You can see here that the roll number, is of number type, name, the sex is of type char and with size 1, DOB of date and marks as number 6, 2. Now pay attention as I insert records into it with the insert into statement. Okay. We have not finished create table as yet because along with the column names, the data types, we have the conditions here, the constraints here that can be put on these particular columns. Okay, that we'll discuss in our next session. Okay, now I'm going to use the insert into statement in its simplest form. Okay, so it is insert into, then it is the table name. So I'm inserting values into the table student. So it is written as insert into, then the table name, then the keyword values, and then one value corresponding to each column in the order in which they appear in the table. So first of all, I must give a value for roll number, then a comma, then for name, then for sex, then for DOB, and then for marks. Okay. The char and the date values and the varchar values should come in single quotes, numeric values without quotes. Okay. So I can use here, say 101, name in single quotes. Okay. Then, so some problem here, I'll just press enter here and use the editor. Okay. And I can use like this. Then I must give date of birth. So I told you the default format. I can use a default format like this. I use a format like this, but it will display only in YY. It won't display all the 4 Ys. Okay. You'll see it just now. So this and marks, maybe I can put as 76. So just see, look at this statement. Insert into student, that is a table name, values, one value for each column in the order in which they appear in the table, right? Okay. This is when you write insert into using this syntax. There are other syntax for insert into also. Okay. So this is the roll number. This is the name in single quotes. This is a char, sex, male. This is in single quotes. Date always comes in single quotes and numeric without quotes. Okay. So I'm going to save it and I'm going to put a slash here to run it. So it says one row created, right? So if you use here, select star from student, you will see this one row. As I told you, in display, it would only display YY, not YY. Normal display is this. Okay. So you can see we have just entered data into this. Okay. Right. Similarly, we can add more data. Okay. So if I use, I can just pick up this statement from here. See, to save time, sometimes we can just, and I can use a control C here, and in my ed I can just copy it. Okay, and I can write here to say Uma Sharma. Then I can put a female here. Maybe I can use 26 January, say 87 here, and I can use 74 here. So if I save it again, so if I just take a look here, if I use this, it is showing that 2 rows are there, this data. Okay, but until and unless I use this command, commit, okay, this is not saved permanently. Okay, and you can roll it back. Suppose you are not interested in this, you don't want to save this data. Okay, you can simply close your SQL window from here. Can you see? If you close your SQL window without writing commit and just clicking on this cross here, these changes won't be saved. Okay, or if you write here exit and then you exit, then it would be saved. Okay, so best way to save your data is to use commit. Okay, I can write commit here. Okay. Now your data is permanently saved, whether light goes off or whether your system comes to an abrupt end, this would be saved. Okay, let's take another example so that the things are clear to you. Let it be like this only. Like this. Okay. Let's save this. It is created. If you use select, it shows 103 Rajesh and all the details. But right now, if you use rollback, okay, rollback means whatever you have done after the last commit, okay, whatever you have done, that would be rolled back, provided it's a DML statement like insert. Okay, so if you roll back here, okay, and if you just see, you won't see that record. Okay, rollback is sort of an undo, but it can only undo DML statements, not the DDL statements. Remember this thing. Okay. So let's discuss another variation of the insert statement. For example, I just want to enter right now. I'm interested in entering roll number and name of the students instead of all the values. Okay. So if I'll just use it from here. If I use it like this, I need to give all the values. I cannot do something like this. If I do like this, okay, it will result in an error because I have not, there are total 5 columns in my table. When I use insert into statement like this, then I am supposed to enter all the 5 values in the order in which they appear. Okay, so it will say not enough values, right? It will say not enough values here. Is that okay? Okay. So how do we make a change here? You specify the column names here. Okay. So now this statement means that I want to insert into the student table the values for these 2 columns. Okay. Now it would be fine. Okay. And when you display it actually, okay, the rest of the values would be null right now. Now working on student. Okay, so 105 couple, the rest values you have not entered, they are null values. We'll enter them later on. But remember this syntax. Okay, remember this syntax. Okay, another important thing now, kindly note, all of you, important one. If we, for example, this statement, right? I'll just modify this, say 107, say I'll just add a name here. Then I'm supposed to add this, and then I think DOB. So I can enter here 11th March 1985, and then marks I can enter as 34. Just must close this. Okay, you can see one row created. Okay. Now, instead of, just if I need to enter many values, I must repeat this command. Okay. And then I must change the values. For example, if I need to do it for, say, some other roll number 108. So I need to change all this. I need to write this each and every time. Okay. So when you're adding a large number of records, then you can do something like this. Can you note this thing? Use the variable names and roll number and name. I'll make it simple so that you're not confused. And R. Okay, but this would be better. Yeah. So it will keep you a good prompt in your mind. And roll number and name. And so I'm using variable names instead of values. Okay, I'm using variable names instead of values. The concept would be same. If it is a char or a date type, it should be enclosed in single quotes, and it should be preceded by an ampersand everywhere. Ampersand means I'm going to input the value for the variable. And when it runs, it will prompt you like enter value for role, enter value for name, like this. Okay, enter value for role, enter value for name, enter value for sex, enter value for DOB. Enter without any codes here, remember, don't put the codes here. Marks, okay, marks, so I can enter 56. Okay, so it has created this. And now you can just put a slash and run it again. That is the idea behind it. This is the last command, insert into student. Just put a slash, you keep on adding the records. Okay, so this way you can add a large number of records for the screen has disappeared. Just a second, I'll open that again. Need to connect again, I suppose. Okay. Is that all right? Okay. So remember this, to use variable names instead of actual values so that you can enter a large number of records, and you need not type it again on the command itself. You can just have a prompt for you. So insert into student values &1. So whatever you write here after ampersand would be the prompt. So better to give a prompt which is meaningful, and roll number and name, char and date types in single quotes, right? And then and marks. Something like this you can give. Okay. You are getting this here. Can you see? It is just verifying certain things. Remember, look on screen. Insert into student. This was what you wrote the command. This was what was filled by you. Okay. So if you don't want to see this, okay, you can write here set verify off. It is simply verifying what you have done with the old and the new words, right? So use set verify off. So if again you now put a slash here to run your last command, that is insert into, okay, it will again ask you. So you can just enter things like here, and date of birth you need to enter properly, and marks as 67. Now that old and new won't come here. Okay, that old and new comes because it verifies your inputted values. So you can just use this set verify off to turn that off. Okay, so this way you can enter many values easily just by pressing a slash here and executing your previous command. So this you should use for entering values an easier way, right? So I think that's all for today's session, and we have got a very good session today in which we have discussed about the group by and the having clauses. Then we discussed about the aggregate functions. Then we also discussed about the data types in Oracle, the create table statement, and the insert into statement. In my next discussion with you, we'll continue with the SQL part. We'll be learning about the constraints that we can put on the columns. Okay. And we'll be learning some more DML statements. And we'll also have some discussions on our database management system, theoretical concepts, right? So till then, thank you very much. Keep watching my videos.